Good morning everyone. Welcome to Math Dali. For this video, this will be presented by Magpantay, Aguilar, and Cabrera. For today's topic, we're going to learn about how to graph a rational function. Given the equation y is equals to 2x minus 6 all over x plus 1, we will get first the domain of the function.
The domain of a function is the set of all possible inputs for the function and includes all real numbers except those that cause the denominator to equal 0.
So to get the domain, we will look for the denominator, which is x plus 1. So we will equate it to 0. X plus 1 equals to 0. Then transpose it to x equals negative 1. Get the domain, which is negative 1. Now that we already get the domain of the function, we will continue to the next step, which is getting the intercept 0.
The intercept of a rational function is a point where the graph of the rational function intersects the x or y axis.
To get the x-intercept, we will equate the numerator to 0. 2x minus 6 equals to 0. Then we will transpose the negative to positive. So 2x equals to 6. Divide both sides by 2. So x will be 6 over 2 or 3. So the x-intercept is 3 or 3 and 0. So for y-intercept, we will divide the second term of both numerator and denominator, which is negative 6 and positive 1. To simplify, the y-intercept is negative 6 or 0 and negative 6.
Always remember, in writing intercepts, we should write it as ordered pairs. Writing it in the way x equal or y equal is wrong because intercepts are points in the graph.
Next is getting the asymptotes of the function.
An asymptote is a line that the graph of a function approaches but never touches it. It can be represented as broken lines in the graph.
So for vertical asymptote, we will look for the denominator, which is x plus 1, then transpose it as x equals to negative 1. So the vertical asymptote is x equals to negative 1. For horizontal asymptote, we will get the first term of both numerator and denominator, which is 2x and x. So we get 2 over 1 or 2. So the horizontal asymptote is y equals to 2.
But remember, there is some rules to be followed. You can just divide the value if the degree of the variable is the same on both numerator and denominator.
Next is getting the critical values of the function.
Critical numbers tell you the points where the graph of a function changes direction.
To solve for the critical number or value of the function, we will equate to 0 both numerator and denominator. First, the numerator, which is 2x minus 6. 2x minus 6 is equals to 0. Then transpose the negative 6, 2x is equals to 6. Divide both sides to 2 to get the value of x. X is equals to 6 over 2 or 3. Next, the denominator. X plus 1 is equals to 0. X is equals to negative 1. So the critical numbers or value is 3 and negative 1. Let's proceed to the table of values.
A table of values can be created to sketch the graph of the function.
In this table of values, you will first write the intervals, which is negative 1 to negative infinity, negative 1 and 3, 3 to the positive infinity, 2x minus 6, x plus 1, and y is equals to 2x minus 6 over x plus 1. Then we will use the fishbowl method. Left side is negative, right side is positive. So negative 1 to negative infinity is above the x-axis, same as 3 to the positive infinity, while negative 1 and 3 is below the x-axis. We will now go to the last part, which is graphing the function.
A graph can be defined as pictorial representation or a diagram that represents data or values in an organized manner. The points on the graph often represent the relationship between two or more things.
To graph a function, we will first graph the vertical and horizontal asymptotes. Since the value of vertical asymptotes is x is equals to -1 and the horizontal is y is equals to 2, we will represent it as a broken line. As said earlier, asymptotes is the line where the graph cannot passes. Next is graphing the point. Our point is in the x-axis is 3 and in the y-axis is -6. If we graph it, it will be 3 and 0, 0 and -6 in the order pairs. To graph a function, we will connect both 3 and -6 so that it will form a curve as we see in the graph. That is simply how to graph a function. But always remember, be careful in solving the values because one mistake can make your graph wrong. So that's all for today. We hope you learned something new from us. See you soon in our next episode. Bye-bye.